Hello students, welcome to the MES online classes. Today we are starting the new chapter, chapter 12, areas related to circle. Before starting this chapter, we must know what is a circle and some basic terms which are related to this circle. So the definition of circle is collection of all the points in a plane which are at a fixed distance from a fixed point O is known as the circle. The fixed point of the circle is known as the center of the circle and the fixed distance is known as the radius of the circle. Now see this boundary. This boundary of the circle is known as the circumference of the circle. Next point is chord of a circle. Any line segment whose endpoints lie on the circumference of circle is known as the chord of the circle. Once again I am repeating, chord of the circle is any line segment whose endpoints lie on the circumference of the circle is known as the chord of the circle. Now next term is diameter of the circle. The chord of a circle which passes through the center is known as the diameter of the circle. Diameter is the longest chord of the circle. Now see this diameter PQ, which is made up of two radius PO and QO. So we can write diameter is equal to 2 multiply radius, and we can also write radius is equal to diameter upon 2. The boundary of the circle, which I have told you, circumference of the circle. The circumference of circle is represented by C and it is pi into d, where pi is a irrational number whose value is 22 by 7, or in question we may use 3.14. This diameter is twice of the radius, so this formula of circumference can also be written pi into 2r, and this is written 2 pi r. So we have two formulas for calculating the circumference of circle. First one, C equal to pi into d, where diameter is given, or we can apply circumference C equal to 2 pi r. Now the space occupied inside this region, that is called the area of the circle, and area of circle is equal to pi r square. So these are the basic terms which are related to the circle. Students, you all love to have pizza and pastries, cake. Have you ever thought what is the shape of the slices of pizza? It is sector, and it is sector of a circle. So now we will study about the area of a sector. But before that, we must know the definition of sector of a circle. I have drawn a circle over here. If we join any two radius OA and OB, now the definition of sector is region between the two radius and arc is known as the sector of the circle. There are two types of sector. You can see in this diagram. This one is known as major sector, and this one is known as minor sector. So once again I am reminding the definition of sector. Region between the two radius and arc is known as the sector. Now we will calculate the area of the minor sector and area of the major sector. So area of minor sector, we must know this angle. Suppose this angle is theta, so we can write theta by 360 into pi r square. So this is the formula for calculating the area of minor sector, theta by 360 into pi r square. If we want to calculate the area of major sector, area of major sector, there are two ways to calculate the area of major sector. We can calculate the area of whole circle and subtract the area of minor sector, we can get the area of major sector. Another way is we can calculate this angle, which is a reflex angle, and this is equal to 360 minus theta, because complete angle is known as the 360 degree. So we can write area of major sector, that is equal to 360 minus theta upon 360 into pi r square. So these are two formulas. With the help of these, we can calculate the area of minor sector and major sector. When I told you the definition of sector, I use one term, and that term is arc. If we want to calculate the length of this arc AB, how we will find length of arc AB? It is theta by 360 into 2 pi r. So these are the formulas which are related to areas of a sector and the length of the arc. Now how we will implement these formulas of area of a sector? I have written a question from exercise 12.2, question number 1. Find the area of a sector of a circle with radius 6 cm if angle of sector is 60 degrees. So we will write the formula area of a sector. Since the angle is 60 degrees, so it is a minor sector. Angle more than 180 degree is known as the major sector. So area of a sector is theta by 360 into pi r square. The value of theta is 60 degree over 360. The value of pi will be used in this question 22 by 7. And the radius is given 6 into 6. So 6 are 36. 6 times we can cancel 1 6 also. 6 to the 12, 6 to the 12 plus 1 13. So that is 132 upon 7 centimeter square. So this is the area of the sector of a circle. Now the next topic of this chapter is segment of a circle. First of all, we must know the definition of a segment. In the beginning of this video, I have explained the chord of a circle. Any line segment whose endpoints lie on the circumference of circle is known as the chord of a circle. So if we draw any chord of a circle, this is AB is chord of circle, this AB is the arc of the circle. So the definition of segment of a circle is region between the chord and arc of a circle is known as the segment of the circle. So this one is known as the minor segment, and this one is known as the major segment. Now we want to calculate the area of these segments, minor or major. How we will calculate? So for that we have to join two radius of this circle, and suppose this is making the angle theta on the center, then area of minor segment is equal to r square by theta by 360 minus 1 by 2 sin theta. With the help of this formula, we can calculate the area of minor segment. Now, if we want to calculate the area of major segment, we can calculate the area of circle and subtract the area of minor segment. We will get the area of major segment. Now, how we will implement these formulas in the exercise, I am going to explain you with the help of one question from the exercise. So, explaining the area of a segment of a circle, I have written a question from exercise 12.2, question number 6. A chord of a circle of radius 15 cm subtends an angle of 60 degree at the center. Find the areas of the corresponding minor and major segments of the circle. Use pi equal to 3.14 and the value of under root 3 we will use 1.73. So first of all, I am writing the formula of area of minor segment, and it is r square by theta by 360 minus 1 by 2 sin theta. The radius r is given 15, so we write here 15 square, that is 225. 15 square. Next, pi 3.14 into theta is 60 degree over 360 minus 1 by 2 sin 60 degree. So 15 into 15, 225. 60, 366 times, so this is 3.14 by 6, 1 by 2, and the value of sin 60 is equal to under root 3 upon 2. Now this can be written 225, 3.14 by 6 minus value of under root 3, 1.73 divided by 4, because 2 into 2 is 4. Now we will take the LCM of this 6 and 4, that will be 12. 225, 6 2 12, 2 into 3.14, 6.28, 4 3 12, 3 times, 3 into 1.73, that is 5.19, and it is 225 into, subtract these numbers, you will get 1.08, sorry 1.09 over 12. If we multiply and divide these numbers, we will get 20.4375 centimeter square. So this is the area of minor sector. Now area for the major sector, we will calculate the area of whole circle. Area of circle, that is pi r square 3.14 into r square 15 and its square is 225, so that is 706.50 centimeter square. So this is the area of the circle. Now if we want to find the area of major segment, area of major segment area of circle minus area of minor segment. So this is 706.50 minus 20.4375. You will get 686 centimeter square. So I hope you have understood the formula of area of sector and the formula of area of segment in this chapter 12.